Um, Hi, everyone. My name is Renee. I am the vice president at UW Blockchain Society Seattle campus. And then I am responsible for managing or trying to distribute tasks for officers based on their professions and major and as well as their backgrounds. I also work closely with the vice president of all three campuses, Chelsea, to try to manage the officers. And we UW Blockchain Society, our goal is basically to educate people about what blockchain is. And then we are trying to create more educational events, such as some kind of workshops and panel talks for the students to learn more about this new technology.
Yeah, and I'm James. So I work at PayPal. I graduated from Cornell in 2018 and have been interested in blockchain ever since, and continue to be involved in various ways, such as presenting here. So I'm going to be talking today about the scalability of blockchain networks. So just again, as a brief intro, I'm James Gahn. Feel free to go back in the recording and find me online here if you're interested in learning more about me. So just to start, I have this quote about Bitcoin and blockchain that really just highlights that there is really a trade-off between throughput and latency for blockchain networks right now. Some of this has been mitigated over time with various forms of blockchain research, but even today there are many derived blockchains such as altcoins or cryptocurrency clones that haven't really tried to tackle these scalability limits that exist within blockchain. And just to demonstrate some of these today, I'm going to go into some examples and to try to highlight some numbers to try to make this a bit more clear to everyone. So Bitcoin was kind of the introduction for blockchain as we know it today. I'm going to gloss over this a little bit and not go into too much of this introductory stuff around Bitcoin and blockchain. But just as a quick example, we may have a blockchain network like this. So we have different members within that blockchain, and they have a different record of the state of the blockchain. So one may have two fewer nodes than the node with the longest blockchain. One may just have one fewer node. But what would be happening in this sort of situation, where one of these nodes actually has a different record than another one? We may find that all three of the nodes end up settling on the longest blockchain, so that is generally the protocol that Bitcoin tries to follow. However, there are various situations where this doesn't actually work so well. There's one thing called selfish mining that I won't go into too much detail about here, but that can actually cause nodes to try to do this maliciously to try to get more block rewards than other nodes in the network. But what I really want to talk about is latency. So if you look at this diagram that I have here, in some cases we may have multiple nodes that are mining or not mining. And so we may have some node in China that isn't mining, but it could be in a major city, it could have a pretty fast network speed, and it could pick up any of these newest blocks that a node in the US, for example, might have found. And so in that way, you might have most of the network on this sort of longest blockchain that we've discovered, but then there could also be a node in a different country with lower latency that is actually trying to mine, but hasn't actually seen this updated blockchain state. And so they will end up actually using a lot of computing effort to try to find the next block without actually working towards this longest blockchain that the network is set to accept by the protocols ingrained within the blockchain network. And this is kind of the root of various throughput issues in that you can try to increase how many transactions that a blockchain can process, but that will really increase the bandwidth that's really required to propagate those changes throughout the network. And this can, in turn, reduce the ability of any member of the network to be able to participate in mining, for example, because they suddenly won't be able to work on the most recent node in the network. Their changes may not get picked up as fastly, and so they will not be as efficient a miner, and their essentially their compensation rate is lower than other nodes for participating to the strength and the health of the network. And as I mentioned before, there are other situations that can impact this as well, that can make the network just not sync up as it's supposed to. So to highlight as to why that matters and why latency and bandwidth really matters for throughput, here is a figure from a research paper and from a Cornell professor that actually highlights some examples. So in Bitcoin, the traditional process is to have 10-minute between blocks with each block containing 1 megabyte of data. And this amounts to about 3 to 7 transactions per second. In 2017, that was actually increased to 2 megabytes every 10 seconds. And the reasons that these numbers were selected were because this is a amount of data that can be processed by a blockchain network that is globally distributed and with pretty common network speeds that aren't just accessible to Western countries or major cities. So the goal of this was really to decentralize this network and make it so anyone in any part of the world can actually participate in this network. So you might think, in theory, if we increase things to 2 megabytes, then hopefully that would double the transactions per second that we can process. And in the future, we may think about, what if we increase that to 2 gigabytes per block? Would that allow us to increase our throughput up to 6,000 or 14,000 transactions per second? Not so much, because again, we're talking about, if we're wanting to include people in this network that have a network connection from a dial-up connection in a rural area, for example, then they will suddenly run into that example I showed earlier, where they are not picking up the most recent blocks that have been created in the network. So they will not be able to mine, they will not be able to contribute to the health of the network. And as a result, you'll get more centralization around Western countries with faster internet speeds, major cities with faster internet speeds, and generally centralize this network in unintended ways. And so you might think in a similar way, what if you just reduce the time between seconds? This ends up facing roughly the same problem. You still end up needing to transmit, both upload and download more data in less amount of time. And you just really run into the same problem where people just aren't able to participate in the network the same way. And so we get to this really fundamental topic of throughput versus latency, where you want high throughput, and you can get that through having larger block size or transmitting blocks more regularly. But really, the network just can't necessarily adopt to those quicker data transmission standards. And they may be able to in certain situations, but that isn't a guarantee. And so just as an overview of blockchain technology in general, is that you are trying to derive certain benefits from blockchain that really relate to having this immutable, trustless record of data. And that trustlessness really derives from being able to have a decentralized network with open participation. And that's not something that you can get if you have these pretty massive latency requirements. And so as you increase the throughput by increasing, bandwidth required, then you begin to limit the network's ability to be open to the public. And this in turn decreases some of those trustless guarantees and security guarantees that we were originally assuming that we had from using blockchain technology. It can also, there are certain other concerns here as well. So larger block sizes might increase the cost of starting a node, storing the blockchain history, even if you're not mining. It may even require excessive amounts of computing capacity for simply validating blocks. And in turn, this would all just tend to exclude everyday users from using blockchains. This is some specific stuff to PayPal, so I'll skip through that. So we get into a greater discussion around, why can't we just have certain people allowed in this network and others not to be allowed? So you might say, we really just need this throughput. It is okay if we're not thinking about certain countries, or it's okay if, we're using this on an enterprise basis that we aren't, allowing people with low connectivity speeds to participate in the network. And this is definitely possible, but then you're starting to talk about some of the trade-offs between a private and a public blockchain. A private blockchain being this idea where you have a blockchain where only certain member nodes are allowed. So you could require certain network capacity, and you could say, we don't need as many participants because we trust the other members in this network. So this would typically be something like Ripple, where you have various industry partners, you have some, more powerful nodes that have some degree of trust, as opposed to something public like Bitcoin, where anyone can run a node, anyone can mine, validation is done by the bulk of the network, and we're trying to generally avoid centralization within any geographic region in particular. And in public blockchain, especially deriving from Bitcoin and the history around that, there's been an emphasis in having a very strong form of the guarantees that you get from blockchain, really towards decentralization and allowing open participation. On the other hand, private blockchains, sometimes referred to as permissioned blockchains, tend to circumvent these throughput issues by just controlling who's in the network. So this can increase the throughput pretty efficiently while still allowing some benefits of blockchain to come through, but really gets rid of some of the other benefits that we were aiming for, such as decentralization and open participation. It also reduces the usability of the public for this blockchain. So while someone may be able to transfer Bitcoin to anyone they want, in a private blockchain, you may not always get that guarantee. There may be regulatory compliance requirements that restrict you from just openly transferring money from one country to another, for example, or that may dictate how much volume you can actually transfer at any given time. So Ripple is a pretty good example. They have these validator nodes that are more trusted nodes within the blockchain. And so they're able to keep track of things pretty well, and they're able to transact pretty quickly. But this also means that in some way you are not really getting this sort of trustlessness guarantee, you are actually just, tending more towards trusting those nodes that are controlling the system. And that doesn't derive down to, full open Byzantine trust, the way that you may have associated with something like Bitcoin. And that just gets me to a general idea of everything in blockchain is a trade-off. You aren't really going to be able to get perfect throughput without giving something up or without having some form of new innovation. So while a lot of traditional solutions may be, can we privatize certain aspects of a blockchain to make it have higher throughput without getting rid of some of the benefits that we see? That is what some things like Ripple try to do. But I would argue that we should really be trying to pay attention to a lot of the research that's happening in the field, as opposed to any specific project, and try to figure out, can we come up with some innovative new way to increase throughput that does not reduce the ability for anyone in the world to participate in the network, and that does not reduce the decentralization of the network to an unacceptable standard. And there are other trade-offs too. There's compliance versus trustlessness. So do we want decentralization and open participation, or do we want to be able to adhere to compilatory requirements? For a company like PayPal, it would be pretty hard to say, okay, let's ignore compliance. We generally wouldn't be allowed to do that as a company that's based in the US. But an open source project, for example, may much more easily be able to say, we're going to put this technology out there, and this is not really affiliated with a company that needs to be held responsible or needs to adhere to these requirements in the same way. I'll give a quick aside to just say that this is generally how I evaluate anything within blockchain. I try to evaluate all these various technical and theoretical trade-offs, how they impact trust and decentralization, and really just trying to analyze whether or not you're getting these guarantees that you assumed you were, if you are going to be using a certain new system. And so generally on the more trustless and decentralization focused side, I was just use Bitcoin as a sort of baseline. And on the hard compliance side, you can kind of use anything that a major US company has a stake in, because they typically have these regulations that they need to comply to. And then along that line in between, you can kind of start gauging where different kinds of blockchain projects or different new protocols may fall. There are certain other alternatives to scalability. So one that I'm interested in, and I hope will pick up more traction in the future, are sidechains. I would say most famously of which is the Lightning Network, which I believe is being built on various different blockchains, most notably Bitcoin, if I'm not wrong. And so these are able to scale blockchain networks to enable higher throughput in the sort of manner that does restrict decentralization overall, but it also maintains the trustlessness nature of the main blockchain. So you will have essentially this more private form of blockchain on the side that can settle transactions independently of the main blockchain. That being said, it doesn't even need to be a private blockchain. It could be just a smaller public blockchain with fewer participants and lower costs to get through more transactions quickly. And so you could have something like a main blockchain being Bitcoin, and then a side chain that's just saying, I'm going to process these transactions, and then on a daily basis, I'm going to settle them all internally before pushing them to the main blockchain. And this could condense down, say, 1,000 transactions into maybe 10, depending on the use case. So just to quickly run through what that might look like, let's say that you have Alice and Bob. Alice has 1 Bitcoin, Bob has 0. And you can see that we have a main blockchain and a side chain here. And let's say that Alice and Bob actually decide to make 2 transactions. So Alice buys something from Bob for 0.2 Bitcoins. Later, Bob buys something from Alice for 0.1 Bitcoin. And they're processing this on a sidechain. So they're making these payments on some sort of sidechain solution. And what this means in essence is that Bob is getting a sort of IOU from Alice that's held within this sidechain. Then after some period of time or under certain conditions, this side chain can actually say, okay, I'm going to settle with the main blockchain. And then it will say, okay, the end result of this is that Alice is giving Bob just 0.1 Bitcoin. And that will process from the side chain to the main blockchain. And so we've reduced the amount of transactions that need to go through the main blockchain by half. In theory, and what a lot of sidechains have tried to do is to figure out how do you reduce this more efficiently, so that it's not just these kind of opportune situations between 2 individuals that you're managing to condense, but to figure out more efficient pathways for transactions to settle. The Lightning Network, I believe I have here, does this by trying to create various payment channels so that you can have cryptocurrency essentially moving around this sort of external network and just once in a while settling with the main blockchain. Upon seeing this, I hope that people are thinking about what the possible problems are here. One study that I don't have cited here, but one study shows that there are various shortcomings to this approach. It is actually hard to figure out how to create these sorts of channels for payments to move through such that you can settle in this sort of efficient manner. And so a real sidechain may not actually look like this, having 20, 30 different nodes with lots of transactions and settling only every few blocks efficiently like this. You may actually have this many nodes and they just need to settle every single block. And they may actually not be able to condense those payments down very much. So while you may hope that this could reduce the required data to be sent by some significant 70, 80%, in reality, you may get something closer to 30 or 40%, and all of that really depends on how that sidechain was implemented and what sort of networking theory networking or graph theory that it may use to actually resolve those open transactions and how it decides to settle them. So kind of as a summary of sidechains, you have this adjacent system to a main blockchain. It will deal with transactions the best it can off of that main blockchain, but occasionally settle up with that blockchain, with the main blockchain. It could use the original cryptocurrency or it could use a secondary cryptocurrency, but overall it will offer some greater degree of customization while still maintaining these guarantees that you have within that main blockchain. If you were to implement sidechains through some sort of cross-chain smart contract, then you can actually work towards maintaining a lot of the guarantees that you have with the main blockchain, while still getting that higher throughput and a sidechain that itself does not necessarily maintain all those same guarantees. So you can get a lot of benefits here. Um, there, I just want to go into detail as into one of these bullet points I have under benefits, in that if you have multiple side chains and they all have their own different implementations, they all have their own code, then you actually have a lot less risk here, because if one of those side chains happens to be implemented poorly or to have a security vulnerability, then that one being compromised does not actually compromise those other side chains that you have going, and it does not actually compromise the main blockchain. So this actually offers a lot of potential benefit to allow uh, various third parties to develop on a main blockchain, maintaining a lot of those benefits without actually exposing new risk from, potentially vulnerable code. And just some pros and cons here. I won't go into all of these, but you do generally get additional throughput here, better scalability, without needing to make a fully public system and without needing to make a fully private system. And vulnerabilities do tend to be a bit more common if you are creating these sort of custom solutions, uh, through sidechains. But the damages from those vulnerabilities are definitely mitigated, because it's sort of self-contained within this sidechain. And just to give everyone a kind of idea of what the throughput is of cryptocurrency nowadays, uh, some of these numbers could be outdated, but it will give a rough picture. Bitcoin has roughly 5 transactions per second. It has about a 10-minute latency, and it has about a $0.50 fee per transaction. The Lightning Network, on the other hand, has about 1,000 transactions per second throughput, about a 40-second latency, which is much lower, and about 1/10 the fee of Bitcoin. It's kind of hard to say with certainty that these numbers are exact or precise, because in cryptocurrency, fees will change a lot. Throughput and latency kind of depend on the state of the network. But hopefully this can demonstrate that sidechains do offer higher scalability. I want to pause here to ask Renee just quickly how much time we have left. I do have one last section here, but it does essentially just go into one more possible solution for scalability.
Sure. So around 15 minutes.
Okay. So I'll try to go through this a bit quickly. So Bitcoin NG is a bit similar to a sidechain, but instead of being a layer on top of a blockchain, it actually allows for the same sort of system you have with Bitcoin, while allowing for centralized processing of transactions over time by whichever node mined the latest block. So you have this essentially, you maintain this proof of work system that you have in Bitcoin, but instead of getting a block reward, you're actually getting transaction fees, based on how many transactions you process, or based on the content of the transactions that you process while you are the leader of the network. So by completing a proof of work puzzle, you are able to be the leader, which will give you a set amount of time to lead and process very small blocks within the blockchain. Wow, I do not have any figures for that. So I'll go a bit more into detail about this then. I thought I had a slide that I don't. But essentially, if you were imagining a blockchain, then for each block that you get, you're going to be processing a certain amount of transactions. You'll see them from other nodes, and they may say, process this transaction and I will pay you, 10 cents. So the leader can see all those transactions that are being proposed and say, okay, I'm going to process these transactions. And usually those get put inside of a single block that then gets pushed to the network. But what Bitcoin NG proposes is to say the leader is instead going to just spend the whole 10 minutes until the next block is found, or until the next proof of work challenge is solved, rather. And during that time, I'm going to just keep processing transactions, maybe in micro blocks of 5 transactions at a time, propagate them throughout the network. And this allows each node in the network to just have to process, instead of having to process a megabyte or two in 10 minutes before the next block is found, or potentially less time if a block happens to be found sooner, then they are just seeing a constant stream of data that they can process over time. So this makes it a bit easier for slower network speeds and lower capacity computers to actually handle higher amounts of data. So even though this is fully decentralized in the way that Bitcoin is, you actually get, anywhere from 10 to 20 times the amount of throughput. It's kind of hard to actually get a specific figure for that as well. But you get much lower latency because you're sending these micro blocks. And you do get a lower transaction fee than Bitcoin, although I couldn't find a good estimate of what fees this sort of system had, because there aren't many actual projects that are adopting this yet. Or sorry, there aren't many projects that have implemented this that have been well adopted yet. So it's a bit harder to say for certain. I will skip over Ripple just because I went into detail about it a bit before, but I can present these throughput numbers that I found for Ripple, which are a bit higher, just about the best ones we've seen yet. So the highest throughput we've seen, the lowest latency, and the lowest transaction fees. But again, because Ripple is a permissioned blockchain, this isn't exactly something where you get these decentralization or trustlessness guarantees that you would from a public blockchain. And so this sort of solution is very popular when you have trusted partners that you can create a network with. So for example, if you are a network of national or international banks, or a combination of tech companies, then you can have this sort of permissioned blockchain where there's a very clear legal institution that you can rely on in terms of conflicts or contradictions, but may not be the kind of thing you want to rely on if you're expecting decentralization. And then here is just some future reading on the topic. And that is about the end of what I've prepared.
Sure, thank you so much. So I have some questions that I have for you.
Yeah.
So the first is how to make sure that everyone has the same and equal access to other non-Western countries and cities using blockchain. Since you also mentioned the decentralized.
Yeah.
Yeah.
So there are a few difficulties that we have to consider here. So I would argue that the reason a lot of early blockchains skewed a bit more in favor of lower block sizes and things like that is because they just know that certain countries have lower connection speeds. Certain countries don't have as much capital for everyday users to invest in modern computers, for example. And so they knew a lot of those, uh, high computational requirements were kind of restricted to specific countries and specific economies. I would argue that sidechains, Lightning Network, Bitcoin NG all attempt to solve this by keeping decentralization kind of at heart, by trying to find these solutions that will not restrict people with a lower connection speed from participating, but will actually allow these networks to scale up in a way that's really necessary for blockchain.
Mhm.
So I would say the most important thing is to not just kind of give up on these innovative solutions and rely on a private blockchain, sorry, because then you aren't really maintaining all of those decentralization benefits in a way that is, uh, well, you're first off, you're just not really maintaining those sorts of benefits, but simply taking a naive approach of requiring the network to process more data,
Mhm.
um, such as by increasing the block size or reducing the time between blocks, is basically just going to do that and going to exclude people from certain countries. So I would just point to sidechains or the Lightning Network or Bitcoin NG and similar sorts of research as potential solutions for being a bit more inclusive.
Yeah, sure. So the next question, what do you see blockchain in the future, and how do you think blockchain is going to affect people's lives on a daily basis, just like how internet has changed our lives for the past few decades?
Yeah, so this is probably one of the most common questions I hear about in blockchain.
Mhm. Yeah.
Everyone kind of wants to figure out what blockchain is going to do. I take a strong perspective that uh, blockchain, it's difficult to say that blockchain will take over the world the way that the internet did, because the internet had very clear uh, kind of benefits. So with the internet, if you get a computer, then you can instantly do X, Y, and Z. With blockchain, even if you get a quote unquote blockchain solution, you may actually, be using a permission blockchain where some of those guarantees are actually just putting trust in a company. Um, so I would argue that scalability and really making solutions something that can happen in a decentralized manner is really critical to widespread adoption of blockchain. That being said, if I think some of those challenges can be addressed, um, then I do think that some of the first things that will kind of be influenced by blockchain are going to be things like, uh, obviously payments has already been impacted in some ways. Um, and enterprise has started to use more private blockchain solutions towards supply chain management. But I think for a real public blockchain solution that isn't already happening to change the world, um, I would probably start to point towards just kind of more expansion on the payments field. Um, I think that regulation and compliance is really critical to a lot of use cases. It's critical to digital asset tokenization. It's critical to putting any sort of blockchain solution towards voting. Um, and some of those are kind of what I would point to if we were talking about blockchain technology as a whole. Um, but from the perspective of really changing the world, I think it's really going to rely on having a public blockchain, having it scalable, and how that will impact the payment space.
Thank you so much for the talk. It's really beneficial, I believe, for our participants and audiences. Yeah.
Yeah, I hope it was interesting. And again, if anyone wants to learn more about me or reach out and chat with me, feel free to find me on LinkedIn or at my personal website linked there.
Sure. Thank you so much for today. And then
Yeah,
have a
thanks,
nice
Renee.